so let's take a look at here. Like I said, I'm going to go through some of these questions that I think calculator doesn't help you so much on. And we'll start with number 1, okay? Number 1, Anna deposited $1,750 into her savings account. Her bank has an interest rate of 7%, compounded continuously. And that's kind of the key words there. Compounded continuously, that indicates that we're going to be using this formula. A equals P times E to the RT, okay? I'll be giving you this formula that you guys can, I'll put it up on the board for you guys during the test and stuff like that, all right, or you can use, that's the formula we're going to use. But you'll need to know, of course, like what the different pieces are. So P, that stands for the, starting amount. Okay, E is the number E, like the button you use on your calculator for E. It's not a variable that stands for something, it's just the number E there. Okay. R, okay, that's your interest rate. Okay, as a decimal. And then T, that is the, well, that's the time, right? Just like we normally expect. And then, of course, A, well, that's your final amount. Okay, final amount. So, let's put all these pieces together, right? What is P? What is our starting amount? Number, and the blue and the green one, it's 1,750. And then E to the, what is the R? What's our interest rate here? Yes, 7%. So as a decimal, that is 0.07. Yes, super important that you use the correct decimal there, right? Not 0.7. 0.7 is 70%. 0.07 is 7%. Okay. And then T is 4. Okay? And so then that's it. So when I say that a calculator is not going to help you here, well, the calculator is not going to tell you where those numbers go. But as soon as you get to this point, well, now a calculator does help you, right? So this is, like, I called this one a calculator was not going to help you with this, but I mean, really it does after you get the numbers in, right? Now we'll just type in 1750 E to the 0.05, or 7 times 4. Okay, you can see, remember the 0.07 and the times 4 are in the exponent there, okay? For those of you that have the older graphing calculators, please use parentheses in your exponent. So if your calculator looks like this when you type it in, E to the 0.07 times 4. Please just make sure you actually close the parenthesis there, or if you have, if there wasn't a parenthesis written, please, if you just use the E button like this and did E to the 0.07 times 4, okay, this will give you the wrong answer. Okay, this will not give you the same answer as if you type in parentheses around your exponents stuff there. See how they're different? Okay, it's significant too. So please make sure you type in with parentheses around your exponent stuff. So 2315.47, which is A. Okay. All right. Letter B. Function f of x equals log base 2 of 4 minus x is graphed below. So there it is. Okay. Find the average rate of change. Oh, we know what average rate of change is. Average rate of change means the slope. That's right. Okay. So now in this case, they give us these 2 points. They give us the x, y coordinates here. They give us the x, y coordinates here. So we can go ahead and just straight up plug them into the slope formula. Okay, so it'll be 0 minus 3 over 3 minus negative 4. Okay, so we'll get negative 3 over 7. So negative 3/7. Okay, is our answer there. Letter D. Okay. Now, if you want to go even further back in time, right, because slope is really a throwback to Algebra 1 and stuff like that. If you want to go even further back, though, we could count this, right? I mean, literally, it's just the slope between these 2 points here. That's rise over run. So rise, down 3, so that's a negative 3. Run, 1, 2, 3, 4, 5, 6, 7. So down 3, right 7. There's your slope as well. So that's super easy. You need to count it, okay? And again, in the blue one here, it's the same idea, right? There's a slope between those 2 points. So again, you can count it out. All right. Number 3, the population of a city in Maryland has increased to 25,000, which can be modeled by the function 25,000 equals 10,000 e to the 0.05t. What is the solution to the equation expressed as a logarithm? Okay, so here's one where The calculator doesn't necessarily help you. You could use the calculator to help you here. So for example, you could convert A, B, C, and D. You can convert all those to decimals and take turns guessing and checking by plugging them back in for T there and see which one will end up giving you 25,000. So could you use the calculator here? Yes. Okay, that's one way you could use a calculator. Okay, but let's do it the straightforward way here. So in other words, we want to try and solve this thing. Okay, how would we go about solving this thing the straightforward way? What do we want to do to both sides here to solve for t? First step. Divide both sides by what? 10,000, yeah. Okay, so that cancels, and that's going to give us 2.5 there equals e to the 0.05t. Okay, and then what? We got to cancel out that e. What cancels out e? ln, natural log. Very good. It's a logarithm. We're going to use natural log of both sides. Okay, so we have natural log of 2.5 equals 0.05t. Okay, and then what's our final step here to get the t by itself? Divide both sides by 0.05. You got it. And so we get t equals, and it's going to be that. Okay, which matches to b. Okay, matches to b. Of course, if you actually type this in your calculator, got the decimal, plugged it in for t, multiplied by 0.05, did e to that, and then times 10,000, you get 25,000 that way too. So you can check it that way as well. So this one, the calculator could make it simple as well. Your choice. Okay. All right, number 4. The rational expression x squared minus 4 over x plus 3 can be written as ax plus b plus c over x plus 3, where a, b, and c are constants. What is the value of c? Now, we're going to rewrite this in this format. Okay, you guys recognize this format here? What we're doing here is this, right? When you see this big fraction bar, that's division, right? So we're actually going to take this, do the division, and end up with our answer, right? Like we're going to have a remainder, you can see. We're going to have some remainder potentially if c is not 0. Okay. How can we divide this? What options do we have here to divide this? We could use what? We have 2 options at least, right? What options could we do to divide this? We could use, how do we divide polynomials again? 2 different methods. Long division is one of them. Or, what's the other method we use besides long division? Not cross multiplication. Nope. It's another division. Synthetic division works. Yes, synthetic division. Could we use, so remember there are only certain cases where we could use synthetic division. Can we use synthetic division in this case? Actually, we can. It does work. X plus 3, that's a nice, easy binomial, okay? What number, let's use synthetic division, right? What number would go in the box here? Well, we're dividing by x plus 3, but what goes in the box then? Negative 3, yes, the 0 of that. So negative 3 goes in the box, and then what goes across the top? Well, what's our lead coefficient here? 1. We're missing the middle term, so I need to put in a 0 and then negative 4. Please don't forget that 0. Super important here. Okay? All right. Do you guys remember how to do synthetic division? So what do we do with this one? We drop it down first, and then we will take the 1 and multiply it with negative 3, and we put it right here, negative 3. Okay? What's 0 plus negative 3? Okay, negative 3. And then we'll do the same thing again. Negative 3 times negative 3? 9. And negative 4 plus 9? 5. Okay? So remember, how do we interpret this? So we started with a quadratic, right? This was x squared plus 0x minus 4, and now we'll have 1x minus 3 plus 5 over x plus 3. Okay? We want to know what the value of c is. What's the value of c? Our remainder. 5. Yeah, it's just 5. There it is. Okay? So you can see here your calculator is not going to help you at all with this one. Okay? So this one you will definitely need to know. Okay, if you see number 4 on the blue paper, almost identical, except this one did not have a missing middle term there, so you can actually just write it all out. Could we also use synthetic division for this one? Yes. So please do. Please do, okay? You could use long division if you want to, but synthetic division works. Please use that, okay? All right, I'm going to skip 5, 6, and 7. 5, 6, and 7 are just literally equations, right? So one way you could do 5, 6, and 7 is by like plugging them in. All right, you can like literally guess and check A, B, C, and D in for the x values there and see if it makes the equation true. Or, of course, what's the other way we can use our graphing calculators to solve an equation? Besides just guessing and checking, plugging in, what else can we do here? Graph both sides, find the points of intersection. Okay? So your choice there. Your choice about what to do. Okay? My test-taking strategy self looks at like number 5, and I see that -3 shows up twice. So I'm thinking it's going to be B or C there. B or C. But that's just my guess. None of the other ones show up more than once, so I'm thinking it's B or C. Okay? And then, yeah. Anyway, so 5, 6, and 7, I'm not going to hit those. If you want me to show them, I will be happy to. But let me hit the ones that the calculator will not be helpful for. Identify the equation that is equivalent to this one. Okay? So they're not very clear here about what we're supposed to do. But just take a look. Okay? Just take a look, though. What does it look like we're supposed to do with this equation to make it look like this one? What do you think we're supposed to do with our starting equation here to make it look like this one? Or these here? Okay, reduce it. Here we have a 36. I don't have a 36 anywhere here. Here we have a 216. I don't have 216 anywhere here. What they do with the 36 and the 216? They rewrote them as what? Like 36 they rewrote as 6 to the... Yeah, well, so what is 36 the same as? 36 is the same as 6 to the what power? Second. And 216 is the same as 6 to what power? 6 to the third, yeah. Okay? Now, when we have a power raised to a power here, what do we do with our exponents? Power raised to a power, what do we do with the exponents to simplify them? Not add. Multiply, yeah. We're going to distribute that too. So it becomes, I'm going to go over this way because I'm going to run out of space. So we'll have 6 to the 2x plus 2 over 6 to the x equals 6 to the third. Okay, so you can see all the ones over here have 6 to the third, so it's really just about manipulating this. Okay, so do we see a 6 to the 2x plus 2 over 6 to the x here? A kind of looks like that, but we need the 2 in front there, so it can't be A. B kind of looks like that, but no, not quite. So we have to get either B or D here. Well, we have division here. What do we do with our exponents when we divide? Subtract them. So what's 2x take away an x? We'll just have an x, right? So 2x plus 2 minus x is going to be x plus 2. And so our answer there is B. Our answer is B. Okay. Now, again, for this one, I said our calculator is not going to really help us here, or not very straightforward, but you could use your calculator here. What you could do is use your calculator to solve this equation, and then see which one of these down here have the same solution as this equation right here. And that would probably work out okay for you there. It might not. It doesn't necessarily have to work out, but it probably would work out okay there. So, anyway. Questions on number 8. All right. Turn the page. I have 3 on this next page here that I want to show you for sure. And then again, I'll open the floor up to any questions you guys might have. All right. This one, your calculator will not help you with at all, really. Okay, this one your calculator will not help you at all with. So this one you are really on your own. Your calculator can help you with like maybe breaking up the 32, but your calculator will not be able to help you with taking the cube root of 7, or x to the 7, or cube root of x or y squared. Okay, so we're taking the cube root here. That's super important to recognize. Okay, so when we simplify this, we're looking for cube roots. Okay, so what are our cube roots? Well, 1 to the third, that's 1. 2 to the third, that's 8. 3 to the third, that's 27. 4 to the third is 64, and so on and so forth, right? You get the idea. Do any of these perfect cubes, do any of these divide 32? evenly? Besides 1. 1 obviously will, but any of the other perfect cubes, will they divide 32 evenly? 8 does, right. And so the cube root of 32 is the same as 8 times what? What is 32? It's 8 times 4. Yeah. Okay? I'll also go ahead and break up the x. Are there any perfect cubes in x to the 7th? Well, yeah, we can make x to the 7th be x cubed times another x cubed. That's x to the 6th. And then what do we have left over here? An x to the what power? We have 2 3s. That makes 6, and we need a 1 more there. So x to the 1 there. Okay? And then the y squared. So I'm just breaking up that cube root over the individual pieces there. Okay? And we have cube root of y squared there as well. All right, so what is the cube root of 8? 2. And we'll have the cube root of 4 still inside the cube root there, right? Because we can't do the cube root of 4, so we leave it inside. But 8 becomes 2 on the outside there. All right, what's the cube root of x cubed going to be? Yeah, just x. And then the cube root of that x cubed will also be an x. And then we still have the cube root of x inside there. Okay? And then we can't take the cube root of y squared, so we'll just leave it like that. Okay, so what's going to be outside of our cube root for our final answer? What's going to be outside of our cube root? 2x squared, right? And then inside the cube root, we're going to have a 4, an x, and a y squared. Okay? So a and c we can eliminate real quick because only b and d have 2x squareds in front. But then which one has the correct inside? Well, it's 4xy squared, so that's d. So d is our answer there. Okay? If you wanted to try and use some strategy here, if you wanted to try and use your graphing calculator, one way you could do that, okay, is to just pick a random number for x and pick a random number for y. So say like x is 3 and make y like 7, for example, and you could plug 3 in for your x's and 7 in for your y's, okay, into a, b, c, and d, and get your different values over here, and then plug 3 in for x and 7 in for y here and see the value of that and see what matches, right? So you could plug 3 and 7 in for each your x's and y's here, get the decimal values for a, b, c, and d, and then plug 3 and 7 in for x and y, and then get the decimal there and match. That is one way you could use your graphing calculator there to do that, but again, that's, I don't know if that's better or worse than what we just did right there. That is an option. All right, 13 and 15, those are the last I want to talk about here. So let's look at 13. Okay, which of these listed functions is equivalent to this? So now we're just going to, again, use our exponent properties here. So again, I'm looking at number 13 there, and I see a power raised to a power. And when we have a power to a power, how do we simplify that? Multiply. What's negative 16 times 1/2? What's half of negative 16? Negative 8, yeah. Over another power to a power, we're going to do 2/3 times 6. Now 2/3 times 6 is 4. Okay? And when we have division, what do we do with our exponents? Subtract them. Yeah, so it's just going to be negative 8 minus 4, which will be negative 12. Okay? And so which one of our answers over here, though, does that match to? None of them, at least not straight away, but which one will it match to? Yeah, it's D. Okay? Remember, when you have a negative exponent, that is the same as saying 1 over the positive exponent there. So x to the negative 12th is the same thing as 1 over x to the 12th. Okay? So there's 13. That one wasn't too bad. But again, a calculator doesn't really help you here. You could, like I said here for number 9, you could just pick a random x value. Okay, so just you make up an x value, do like 2 or something like that. You could plug 2 in for x here and simplify, plug 2 in for x here and simplify, right, and match the decimals. So I'll show you what I'm talking about here just so you guys can see. So let's just say I plugged in 2. So I'll do 2 to the negative 16. Oops, I need to put parentheses here. 2 to the negative 16 to the 1/2. Okay, so there's that. I'll divide by then 2 to the 2/3 power to the 6th power. Okay, just like that. and this is my answer. Okay, so I'm looking for something that will match to this. And if I type in, 2 to the 12th, obviously that's not going to work. Oh, all right, go ahead. So 2 to the 12th obviously is going to be way too big, but I can type it in here just so you can see. All right, that's 4,096. That's not right. 2 to the 4th also is going to be too big, 16. I'm looking for this number. I can do 1 over 2 to the 4th. Okay, that's still not right. And if I do 1 divided by 2 to the 12th, there it is, right? If I go back up here, you can see it matches that decimal right there. Okay, so again, that's one way you can kind of cheat the system a little bit there. You know, don't know if it's better or worse. I think really 13 is not that bad in the first place, just doing it that way. So. Last one, 15. Find the inverse. Okay, so to find an inverse, I'm going to rewrite this as y equals 1/2 x minus 6 squared. And then what are we supposed to do to find the inverse here? What do we do with our x's and our y's? Swap them. And now we're going to solve for y. So swap x and y, solve for y. Okay, so we need to get the y by itself. So what's with the y that we need to get rid of there? First thing we're going to get rid of is the 1/2. And how to get rid of 1/2? You could divide both sides by half, or we can multiply both sides by what? 2. So I'm going to say that's 2x equals y minus 6 squared, like that. Okay, and now what are we going to do? How can we get rid of the square? Square root. So you have the square root of 2x equals y minus 6. Now, Mr. Wade, when we square root an equation, are we supposed to put a plus or minus in front? Yes, but we don't need to here because it's saying when x is greater than or equal to 0. So in other words, this will be a positive root 2x here. Okay, we don't need to worry about the plus or minus. Final step here, get the y by itself. What do we do to both sides? Add 6. Okay, and then that's our inverse right there. F inverse is the square root of 2x plus 6. Okay, which is B. Okay, so B is our answer. All right, we only have like 1 or 2 more minutes left, but does anyone have any last minute questions they want to ask about any of the other multiple choice? Okay. So again, I'll be happy to go over the other ones that we didn't get to tomorrow if you want. Okay, there is no homework tonight, but I would really encourage you to look over these questions here, okay? We have 1 more day of review, and that's it. Okay, I would really encourage you to please look at the... All right, so I was asked to finish up going over these questions. I'm doing this on my own here with no students, so I'm not going to stop and ask questions for the most part. Except for you to pause and think about as we go over them. So I already went through earlier in the video some of these other questions that I thought really a calculator can help you with, but you really need to know some stuff for it. I'm going to now go over the questions where I really feel like a calculator makes these questions trivial. Okay, and the reason why I think a calculator, especially for like 5, 6, and 7, makes these questions easy is because you can literally just type the left-hand side in your graphing calculator, type the right-hand side in, and then find the point of intersection. Now, the catch is you got to type it in correctly. So for example, at number 5, you got to make sure you put parentheses around the numerator and parentheses around the denominator. Same thing for the other side as well. Okay, or else you will not get the correct answer. Okay. The other option, of course, is to guess and check A, B, C, and D, your answers in for X, and see which ones make the equations true, which ones make the equation false. But again, when you type in your calculator, you have to type it in correctly. So if you aren't using parentheses right, you're not going to having your calculator is not going to help you. Okay, so. All that being said, I'm going to show you how to actually solve these. So cross multiply here because you have a fraction equal to a fraction. So we'll do 2x times that. We'll have 2x squared plus 8x equals, and then x minus 3 times 1 will be just x minus 3. Bring everything over to one side here. You'll have 2x squared plus 7x, and then plus 3 equals 0. Okay, now to factor this, quadratic here, we will take the a here, which is 2, times 3, which is 6, and we're looking for 2 numbers that multiply to 6, but add to make 7. That's going to be 6 and 1. This factors to be then 2x squared plus 6x plus 1x plus 3, and then we'll group. Factor out of 2x here, so it's 2x times x plus 3, and factor out of 1 here, and we get 1 times x plus 3. then x plus 3 is in common, so we'll take out the x plus 3, and we're left with 2x plus 1. Now we'll set each factor equal to 0, so we have x plus 3 equals 0, and 2x plus 1 equals 0. Okay? And that means we're going to get x equals negative 3 there when we solve for x, and here we'll subtract 1, divide by 2, we'll get x equals negative 1/2. Okay, so those are our two answers. Now you do want to check to make sure that when you plug negative 3 in for x, you're not going to get undefined or anything like that, or negative 1/2 in for x, you're not going to make it undefined, but they both work, so C is our answer. Excuse me. Excuse me again. Okay, so number 6. Oh, and just real quick, just so you can see here, if I were to type this in my calculator, x plus 4 divided by x minus 3, whoop, and then 1 divided by 2x. Yes, the 2x needs to be in parentheses there. Graph it. Okay, there's one of them. And there's the other one. Okay, you can see here, finding the points of intersection, not so easy, but it's like somewhere over here. So trace, intersect. So there's our negative 1/2, and maybe further over here too. I'll arrow over some more. And there's your negative 3. Okay, so it works. And of course, if you saw that negative 1/2 the first time, then you'd know it had to be C. You don't even need to check to see if negative 3 works as well. Okay, if negative 1/2 works, then so does the negative 3. Okay, all right. Number 6, same way. You can graph the left-hand side, graph the right-hand side, find the point of intersection. That's probably going to be super easy here, okay, to do that. But again, I'm going to solve this the straightforward way. So you do that here by squaring both sides, so that way you can eliminate that square root. We'd have x plus 10, so you can square this side, square this side. Squaring the square root leaves us with x plus 10. Squaring x plus 4 means we're going to have x plus 4 times x plus 4. That will multiply out then to be x squared plus 8x plus 16. Okay? It's quadratic, so we want to get everything equal to 0. So I'll subtract the x and subtract the 10 over. We'll have x squared plus 7x plus 6. Again, we have a lead coefficient of 1 here, so we can just look at the 6 and see that, okay, what two numbers multiply to 6 but add to 7? That's 6 and 1. So we have x plus 1 and x plus 6. Set each factor equal to 0. And then solve. You get x equals negative 1 and x equals negative 6. Okay, now, you do want to check both of these, though, back in. It says check for extraneous solutions. That means you want to plug negative 1, negative 6 back in here to see if it makes the equation true. I'm going to do it mentally here. So negative 1 plus 10 is 9. The square root of 9 is 3. Negative 1 plus 4 is 3. 3 equals 3. Check. Okay, let's try negative 6. Negative 6 plus 10 is 4. Square root of 4 is 2. Negative 6 plus 4 is negative 2. 2 does not equal negative 2, so actually negative 6 does not work. You want to do A here. If you chose to solve this by using your graphing calculator, okay, you would type in square root of x plus 10, and then also x plus 4. Okay? And there's our point of intersection. You can see it only intersects at one point, and there's your answer of negative 1. Okay? All right, let's try moving on here. Number 7. Okay, 7 again. You could guess and check your answers by plugging them in. Please make sure you put parentheses around your exponents there. Or we could also solve this using our exponential techniques here we got. So 8 and 2 are both powers of 2. I can rewrite 8 as 2 to the third, and then to the x plus 3, and then 2 to the x plus 25. Okay, distribute the 3, and so we get 2 to the 3x plus 9 equals 2 to the x plus 25. Same base. And so the exponents have to be equal. So 3x plus 9 will equal x plus 25. Subtract the x over, we get 2x. Subtract the 9 over, we'll get 16. X then is 8. Positive 8. Okay? Okay. A few more here to take care of. Excuse me. All right, number 10. Identify the x-intercept for the function f of x equals log base 5 of x minus 3. So this one's easy enough. We can graph into our calculators, right? All right, so log base 5 x minus 3. Log base command, so math, and then arrow to log base. Okay, log base 5 of x minus 3. graph it. There's our x-intercept. You can even count it. 1, 2, 3. It looks like it's at 4. Okay? You can check your table too, just to make sure. Oops, let me go back to my 4, 0. There you go. Okay? Excuse me. Okay? That's an easy enough way to get your x-intercept there. You can also set the function equal to 0 and then solve it. Okay, to solve, you would eliminate the logarithm here. So 5 to the 0 equals 5 to the log base 5. Those would cancel. You'd have x minus 3 equals, well, 5 to the 0 is 1, and then add 3 to both sides, and you get 4 that way too. Okay? All right, number 11. Identify the transformations of the function f of x equals 1 over x by comparing the function f to the function g given below. So, in other words, right, here's our parent function 1 over x. How is g a transformation of f? Well, I see a negative 1. I see the minus 5 here. I see the plus 7. The plus 7 is going to shift everything up 7. And the only thing that has up 7 is there's up 7 and there's up 7. So it can't be B, it can't be C. Minus 5 is going to shift everything right 5. Well, that says left 5, so it can't be A. It must be D. And reflection over the x-axis, that's from that negative right there. Okay, so it's got to be D. Oops, sorry, I was off the screen there a little bit, but you can see it now at least. Ooh, a little smudgy. Okay, number 12. A single capsule of ibuprofen is 400 milligrams. Ibuprofen in the blood decreases by 4% every 20 minutes. This can be modeled by using the expression this, where f of t represents the ibuprofen remaining in their bloodstream. So f of t is the amount of ibuprofen left in the bloodstream, and t is the time in hours since it was consumed. Which of the following would be an equivalent expression to find the amount of ibuprofen remaining in their bloodstream after t hours? The simplified equation is, and then one of these, right? You can see they all have that 125 out front. Okay, none of them have the cube in their exponent though. Okay, and we have this 1 minus 0.04 over 3. You can see all of these are a single number. So let's go ahead and plug in and simplify this thing inside the parentheses there of the 1 minus 0.04 over 3. Let's see if I can get that to fit in here. Okay, and that should be fine to do it just like that. And you can see 0.9866666 repeating. Now, you can see 0.9866666 repeating right here in letter A, right? It's rounded. And that's only 0.986. So you might think the answer is A. But don't forget, we still have that cube up there to deal with too. So we're actually going to take this decimal that we got, the 0.9866666, and raise it to the third power there. 0.9605, which then is C. So C is actually the correct answer here, not that 0.9867. Okay, so please be careful there. You got to simplify what's inside the parentheses, then raise it to the third. That gives you the correct answer there. Oops, I should include the 3 as well there. Okay? All right, and the last one that I have to cover still, that wasn't in the video earlier, 14. Okay? The radius of a sphere as a function of the surface area is given by this. In other words, this tells us how to find the radius of the sphere if we're given the surface area of the sphere. Okay? So in other words, like, well, the distance from the center of the sphere to the edge of the sphere in terms of the amount of two-dimensional space around the sphere. Like, yeah, that. So if the radius is 9, what is the surface area in terms of pi? So r is 9, so we'll say 9 equals the square root of s over 4 pi. Square both sides. Okay? Then to get the s by itself, we'll multiply both sides by 4 pi. Okay? So we'll get s equals. Now, when you go to do 4 pi times 81 here, please do not use the pi button in your calculator because it says in terms of pi. That means we want our answer to still have a pi in it. So we're just going to do the 4 times the 81 there. Okay, 4 times 81 will be 324, and then we'll still have the pi. And so there's our answer. The answer is C. Okay? Yeah. So leave it in terms of pi means we don't multiply the pi through. Right? And that concludes looking at the multiple choice there for the green package. I will post another video, I think, about the blue one, but for right now, we'll just stick with the green. Okay? So good luck and good studying.